A nuclear reactor is a device in which a steadily controlled fission reaction takes place. Let us now study about the design and working of a nuclear reactor with uranium as the fissionable material. Uranium is taken in the form of cylindrical rods. These rods are arranged in a regular pattern within the active reactor core. The volume of the core is filled with a light nuclei material like either water, heavy water or graphite, which are called moderators. The neutrons released during the fission of uranium-235 have kinetic energies of approximately 2 million electron volt and are called fast neutrons. These fast neutrons escape from the uranium and enter the moderator. It is observed that the probability of uranium-235 undergoing fission is high when it absorbs neutrons with energies of approximately 0.04 electron volt that are typically called the slow neutrons. The probability of absorption of fast neutrons by uranium-235 is very low, and hence it does not help in the fission of uranium-235. The fast neutrons can be slowed down, that is, converted into slow neutrons by means of elastic scattering with light nuclei to sustain the fission reaction of other uranium nuclei. These light nuclei material called the moderator, which provided along with the fissionable material, slow down the neutrons released during fission and therefore help to increase the probability of fission of uranium-235 nuclei. Thus, the function of a moderator is to slow down the neutrons released during fission so that they can be absorbed by further uranium nuclei. In a pressurized water reactor, water is used as a moderator as well as a coolant to absorb the enormous amount of energy released in the reactor. The geometry of the core is such that out of an average of 2.5 neutrons released per fission, 1 neutron triggers the next fission reaction and the remaining ones are lost without causing further fission. That is, they are absorbed by the control rods. Control rods are used to control the rate of the fission reaction. Control rods are made of materials like cadmium. Cadmium is a very good neutron absorber, and it can be inserted into the moderator at a certain depth. Thus, the fission reaction can be sustained at a constant rate. Let us now define a quantity called the multiplication factor K for a reactor, which is a measure of the growth rate of the neutrons in the reactor. Multiplication factor K is defined as the ratio of the number of fissions produced by a specific generation of neutrons to the number of fissions produced by the previous neutron generation. As previously mentioned, out of an average of 2.5 neutrons produced, fission is always caused by 1 neutron only, and the value of K is equal to 1. This state is called the critical state of the reactor, wherein the reaction runs at a constant rate. If the cadmium rods maintaining the critical state are now drawn out of the reactor, then more number of neutrons will be available for further fission and the multiplication factor K becomes greater than 1. Thus, the fission rate increases rapidly and leads to an explosion. Again, consider the case when the reactor is just critical. If the cadmium rods are now pushed further into the moderator, they absorb more neutrons than earlier. The number of neutrons available for further fission becomes less. This reduces the multiplication factor K to less than 1. In such a case, the rate of fission decreases and the reactor shuts off. Thus, the control rods regulate the fission rate. In addition to the control rods, additional rods called the safety rods are provided in the reactor. Whenever required, these rods can be inserted into the reactor and can rapidly bring down the value of the multiplication factor K to less than 1. In the reactor core, a lot of energy in the form of heat is released, which can be utilized for the generation of electricity. Water at high pressure or molten sodium is passed through the reactor core to withdraw the heat produced in the core. The material that is used to extract the heat out of the core of a nuclear reactor is called the coolant.